Hi guys, today we'll talk about a math contest problem from Waterloo's grade 8 Gauss contest. This question combines number theory and patterning. This is question number 25 from year 2011. And the question says, Daryl first writes the perfect squares as a sequence 1, 4, 9, 16, 25, 36, 49, and so on. After the number 1, he then alternates by making two terms negative, followed by leaving two terms positive. Daryl's new sequence is 1, -4, -9, +16, +25, -36, and so on. What is the sum of the first 2011 terms in this new sequence? So I think we can be convinced that there's no way we can find the sum of more than 2,000 terms with brute force, right? So we have to look for some kind of pattern. So let's start off by writing down the sequence and then look for some kind of pattern. So we start off with +1 square, right? The next term is -2 square. And the next term is -3 square. Then you have +4 square, right? Two terms positive, so 5 will be positive again, 5 square. Then you have -6 square, so leaving two terms negative, so -7 square as well. Then you have +8 square, +9 square, right? Then you have -10 square, right? And we know that we're looking for the sum of 2011 terms. So the last term is going to be 2011. So, but let's continue. Let's give it like just say the second and the third last term as well, just to see this pattern or the sequence in full. So we have 2009 square, 2010 square, and 2011 square. So we don't know what the end of the sequence looks like exactly yet, but we can find that out, right? Because we don't know whether they're all positive or which two are positive, which two are negative. We don't know that yet. So let's try to look for some patterns in the positive and negative sign. We see that there's a cycle of 4, right? So we start with a positive, then we have two negatives, then positive again, right? Positive, negative, negative, positive. Then we repeat this pattern, which is positive, negative, negative, positive, positive, negative, negative, positive, right? So you see every 4 actually forms a pattern. So at 4, that's where the end of the first pattern, right? So at 8 is the end of the second cycle, right? So this is in cycle of 4, right? So we see that whenever we see a number that is a multiple of 4, we know that's where one cycle ends. So actually the term just before 2009, which is 2008, is a multiple of 4, right? So we know that on 2008 is where a cycle of 4 ends. So 2009 is the start of a new 4, like this 4-number pattern or 4-number cycle, right? So 2009 is like the 5 and the 1 here. So 2009 must be positive. Then must be followed by two negative numbers, which is -2010 square and -2011 square. So we just figure out how the positive and negative signs alternate. Okay, cool. So now I have a better idea of what this sequence looks like. Can we find some kind of pattern that helps us calculate the sum? Well, if you have tried taking the first difference, so the difference between any two terms, right, or adjacent two terms, right, you'll see that, okay, the difference is actually not common. It's not all equal, right? If you try to take a common ratio, you see that that fails as well. Okay, so what is left to do? Well, actually, right, because of a positive and negative happening, right, alternating signs, we should try to group them and hopefully to see the positive and negative signs cancel out in some way. Right? So how do we exactly do this? Take the first and second term, add them together, right? This is one way of grouping them because one is positive, one is negative. So 1 squared, which is 1, minus 4, which is -3, right? Take the second and the third term, right? So -9 plus 16, which is +7. Take 5 and -6 together, so add them up. So we have +25 minus 36, that is -11, and -7 squared and +8. If we pair them up, that is +15. Right? And +9 and -10 squared, if you add them up together, that is -19. Right? Okay, cool. Do we see any kind of pattern? Right? So you see that, okay, if we actually ignore the negative signs, right, which comes comes on the first, third, and fifth terms, right, or the fifth sums, right, So we see that if you ignore all the negative signs, this is actually an arithmetic sequence, right? 3, 7, 11, 15, 19, their common difference is 4. But because of this alternating positive negative signs, we cannot say it is not an arithmetic sequence. So we gotta, but nonetheless, right? We see that, okay, we still have a positive negative. We can keep pairing this further to see if there's any pattern, right? So negative 3 and 7, we can pair these two together. This is positive 4, right? If you pair negative 11 and positive 15 together, this is also negative. This is also positive 4, right? And if you calculate the next term, the next like paired sum after 9 and 10, you'll see that, okay, this would actually be positive 23. So these two, if you pair them together, that's also 4, right? What does that mean? It means that every four terms, right? 1, 2, 3, 4, 5, 6, 7, 8, right? Doesn't matter what it is. It could be 9, 10, 11, 12. If you sum up every 4 terms, right? Their sum is always 4. And this repeats, right? And this is your pattern. So it's that every 4 terms, right? Not only do their positive and negative signs like complete a cycle, but also their sum is exactly 4. Okay, so now the question is, how many quadruples there are in this sequence from 1 to all the way to 2011. So let's calculate that. So 2011, right, is equal to 4 times 502, right? Because 4 times plus 3, right? Because 4 times 502 is 2008, right? Plus 3 is 2011. So that means there are 502 quadruples, right? And each quadruple has a each quadruple sums up to 4, right? So 502 quadruples, that gives you 502 times 4, which is 2008. So we know that the sum of the first 2008 terms, right, is basically 502 quadruples, and each quadruple sums up to 4. So therefore, the sum of 2008 terms is exactly actually 2008. Add to this sum positive 2009 squares, negative 2010 square, and negative 2011 square, right? So we have 2008, right, plus 2009 square, minus 2010 square, and then minus 2011 square. So what is if you can punch this into the calculator because you only have 1, 2, 3, 4 terms left, right? So you have a negative 4,046,132, right? And that is the sum of all first 2011 terms.